Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on trigonometry, degree level, chapter D. Moivre's theorem, lecture number 6, in which I will solve some problems on nth root of complex numbers. Before solving the problems related to nth root of complex numbers, I would like to give you the formula or way how to derive these problems. Let x plus iy be a given complex number. We will have to find the nth root of this complex number, that is to find x plus iy to the power 1 by n. So firstly we write x equal to r cos theta, y equal to r sin theta. Then find r equal to square root x square plus y square, tan theta equal to y by x. When r and theta are determined, then nth roots will be r to the power 1 by n cos 2 pi k plus theta by n plus I sin 2 pi k plus theta by n. Value of k will be 0, 1, 2, n minus 1. And with the help of this formula, we will solve all problems. Now we solve a question. Find the nth roots of unity. Solution. Since 1 equal to 1 plus I into 0, this is 0 and 1 equal to 1. Here x equal to 1, y equal to 0. This is of the form x plus iy. R equal to square root x square plus y square, means 1 square plus 0 square, means 1. Tan theta equal to y by x, means 0 by 1 equal to 0, implies that theta equal to 0. Therefore, nth roots will be r to the power 1 by n cos 2 pi k plus theta by n plus I sin 2 pi k plus theta by n. N equal to 0, 1, 2, n minus 1. Putting r equal to 1, theta equal to 0, we get nth roots of unity as follow. 1 to the power 1 by n cos 2 pi k plus 0 by n plus I sin 2 pi k plus 0 by n. This is cos. Here k equal to 0, 1, 2, n minus 1. This is cos 2 pi k by n plus I sin 2 pi k by n, k equal to 0, 1, 2, n minus 1. Putting k equal to 0, 1, 2, n minus 1, we get nth roots of unity are cos, here k equal to 0, 0 by n means 0 plus I sin 0, and this is equal to 1, comma. When k equal to 1, we get cos 2 pi by n plus I sin 2 pi by n. When k equal to 2, we get cos 4 pi by n plus I sin 4 pi by n. When k equal to 3, then 6 pi by n, cos 6 pi by n plus I sin 6 pi by n, comma, and when k equal to n minus 1, we get cos 2n minus 1 pi by n plus I sin 2n minus 1 pi by n. These are n number of roots. When cos 2 pi by n plus I sin 2 pi by n equal to omega, then we may write nth roots of unity as follow: 1 omega square omega to the power n minus 1. Here this is omega, and if we square this quantity, we get cos 4 pi by n plus I sin 4 pi by n. This is this quantity omega square. Similarly, this is omega cube, and at last this is omega to the power n minus 1. Now question is solve fourth root of minus 2 plus 2i square root 3. Now we solve this. Here x equal to minus 2, y equal to 2 square root 3, r equal to square root x square plus y square minus 2 whole square plus 2 square root 3 whole square root, and this is 4 plus this is 12 square root 16 equal to 4. R to the power 1 by 4 means here R is 4, 4 to the power 1 by 4. This is 4 to the power half to the power half. 4 to the power half is 2 to the power half, and this is square root 2. Tan theta equal to y by x. Y is 2 square root 3. X is minus 2. This is minus square root 3. Here x is negative. Here x axis, this is y axis, this is negative of x axis, this is negative of y axis. X is negative and y is positive. So here x is negative and y is positive. So theta lies in second quadrant. Here x is negative and y is positive. This is the second quadrant. Therefore, theta equal to, here tan theta equal to minus square root 3. So theta equal to 2 pi by 3. Since nth root of a complex number be r to the power 1 by n cos 2 pi k plus theta by n plus I sin 2 pi k plus theta by n, k equal to 0, 1, 2, n minus 1. In our problem, r equal to 4, theta equal to 2 pi by 3, n equal to 4, fourth root, and r to the power 1 by 4 equal to 4 to the power 1 by 4 equal to square root 2. Therefore, roots of the given problem will be r to the power n means r to the power 1 by 4 is square root 2 cos 2 pi k by n, n is 4, here plus theta, theta is 2 pi by 3 plus I sin 2 pi k plus theta is 2 pi by 3 by 4, k equal to 0, 1, 2, n minus 1. Here 4 minus 1 means 3. When k equal to 0, root will be square root 2 cos k is 0 means 2 pi by 12 plus I sin 2 pi by 12, and this will be 2 6 are 12. This is cos pi by 6 plus I sin pi by 6. Value of cos pi by 6 is square root 3 by 2 plus value of sin pi by 6 is half I. So this root will be square root 6 by 2 plus square root 2 by 2 I. When k equal to 1, then root will be here square root 2 cos k1 means 2 pi plus 2 pi by 3 by 4 plus I sin 2 pi plus 2 pi by 3 by 4, and this will be equal to square root 2, here 3 to the 6 plus 2, 8 pi by 12 plus I sin 8 pi by 12, and if we cancel by 4, 4 to the 8, 4 3 is 12, 2 pi by t cos 2 pi by 3 plus I sin 2 pi by 3, and this is equal to minus half. Cos 120 means minus half, and sin 120 is square root 3 by 2. Sin is positive here in second quadrant, and this is I. So this is equal to minus square root 2 by 2 plus square root 6 by 2 I. When k equal to 2, then root will be here square root 2 cos, here k equal to 2 means 4 pi plus 2 pi by 3, 4 pi plus 2 pi by 3 by 4 plus I sin 4 pi plus 2 pi by 3 by 4, and this is equal to 4 3 is 12, 12 plus 2, 14 pi by 12 cos 14 pi by 12 plus I sin 14 pi by 12, and this is equal to 7 pi by 6 plus I sin 7 pi by 6. We may write this 7 pi by 6 as pi plus pi by 6. So here we have written cos pi plus pi by 6 plus I sin pi plus pi by 6. Square root 2 is outside. And this is equal to minus cos pi by 6, and this is equal to minus sin pi by 6. So this is equal to minus square root 2 cos pi by 6 is square root 3 by 2 minus is square root 2, here I sin pi by 6 is half. So this is equal to minus square root 6 by 2 minus square root 2 by 2 I. When k equal to 3, the root will be square root 2 cos, here 3 means 6 pi plus 2 pi by 3 by 4 plus I sin 6 pi plus 2 pi by 3 by 4. This is equal to square root 2. Here 6 3s are 18 plus 2 20. So this is cos 20 pi by 12 plus I sin 20 pi by 12. This is equal to cos 5 pi by 3 plus I sin 5 pi by 3. If we add here minus 2 pi, since we know that cos 2 pi k plus theta equal to cos theta, so there is no change of values. So in place of k we write here minus 1, 2 pi k. K means minus 1, then this is will be minus 2 pi. Here we have added this, and here also same, sin 2 pi k plus theta equal to sin theta, and this becomes cos minus pi by 3, and this is sin minus pi by 3. Cos minus theta equal to cos theta. This means this is equal to cos pi by 3. Sin minus theta equal to minus sin theta, means minus sin pi by 3. And we put the value of cos pi by 3 is half, and sin pi by 3 is square root 3 by 2, and this will become square root 2 by 2 minus square root 6 by 2 I. Therefore, answer will be, here we get 4 values. These values are square root 6 by 2 plus square root 2 by 2i. Second is minus square root 2 by 2 plus square root 6 by 2i. Third is minus square root 6 by 2 minus square root 2 by 2i. And fourth is square root 2 by 2 minus square root 6 by 2i. So the problem is solved. Now we have an important note. During the period of finding nth roots, followings are very important. For example, if we find the fourth root of minus 1, then we may directly write this. Here in place of theta is pi and r equal to 1. And we use the general formula for finding the nth root. So we may write 1 equal to cos 0 plus I sin 0, minus 1 equal to cos pi plus I sin pi, I equal to cos pi by 2 plus I sin pi by 2, minus I equal to cos minus pi by 2 plus I sin minus pi by 2, or minus I equal to cos 3 pi by 2 plus I sin 3 pi by 2, 1 plus I equal to square root 2 cos pi by 4 plus I sin pi by 4. Number 6, 1 minus I equal to square root 2 cos minus pi by 4 plus I sin minus pi by 4. And then we may find any order of root of these quantities. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.